All right, welcome to Chapter 9, Section 2, called Distributions of Data. This is for Integrated Math 1. So a couple things you'll see on your screen here. The first thing you should see is a due date. I don't see it on my teacher preview, but it will be on your student screen. The second thing is the number of attempts. You always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many questions are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is the one you get to keep. Partial credit is enabled, so if you answer 1 of 3 questions correctly, you get credit for 1 question, or however many you answered correctly. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. What that means is once I click start, down in the bottom right corner here, there's going to be a submit assignment button on your student screen. I know it's not right here on my teacher screen, but it will be on your student screen. This is how you finish an assignment, by clicking this button. And just like that other screen, the first screen there said, you have to finish this or click that button before you can work on anything else. It means Alex is going to lock out all of your other assignments while this attempt is open. So if you just close this screen or you close your computer, it's going to assume you want to leave the attempt open. And it's going to lock every other assignment and all of the resources too. Remember, you have unlimited attempts, so you don't need to leave the attempt open. Just always make sure you click that button. And as long as you've answered questions and you click the check mark and you get the green check here, it's going to save your place. You're not going to have to restart on any of these. You're only going to have to try ones that you haven't tried yet or ones that you got wrong. All right. So the other big reason you want to click submit assignment is so that it affects the grade book. Up until that point, your account's kind of frozen and your teachers can't see what you've been working on. So good habit, always, always, always click that button. On the side here, we have 4 other tools. Sometimes calculator's there. For instance, it's there right now. It's not always here. Explanation, example, and message center are always there. So explanation tells you you're going to lose your current question attempt because it's going to give you the answer to this question. So it's not going to give you the answer and then let you come type it in. Or in this case, manipulate the graphic. Example will give you something very similar to what we're looking at. So here is a histogram. It's going to show you exactly what it is it wants us to do and how to submit that. You can click on example again if you'd like to see another one, or you can message your teacher directly from the screen because it attaches a picture, just kind of lets us know where to come help you. All right, let's go ahead and get started on this. So a histogram is, and we can see that, it's kind of like a bar table, or not a table, well it is a table. A bar chart, I guess, is a good way to do it, but it's kind of specific. If you look at this, when I drag these up, there is no spacing between the bars. So a lot of the time when we look at charts, there's a lot of space between them, or they're kind of smaller bars. With these ones, there are no spacing. The other big thing that we want to notice about a histogram is the intervals here. So the intervals are going to be the same spacing. So 21 to 26 is the same distance or space as 27 to 32, which is the same space between 33 and 38. So they all have the same amount or same range for each interval. And that's a very important piece of the histogram. All right, so we can kind of see how this works too. I click and I can drag up and down, and then I let go and it drops it there. So the idea here is what we're going to do, and I'm going to grab a picture of this because it's a little easier if we have this to manipulate. Let's see. So if you don't have the ability to, print or copy and paste like what I'm doing here onto another screen, then you can simply write the numbers down. Just be very careful when you're rewriting numbers because you don't want to skip over any numbers or anything like that. So what we're going to do is we're going to count the number of values each point that is within the interval. So anything from 21 to 26 is going to be in this guy here. Anyone from 27 to 32 is going to be in this interval here. So we're just going to go through and count. So let's do 21 to 26 first. So there's 1, 23, 22, 21, 26 counts, 25 counts, 27's too big, so I think that's all of them. 1, 2, 3, 4, 5. So I'm going to take this guy and I'm going to drag it up to 5, like that. All right, let's do the next one, and I'll switch up my color here. So now we're going to go anything from 27 to 32. So there we go. Let's see. 32, 32, 30 counts, 27 counts, and nope, not 32. So that looks like 4 for that one. Okay, and then let's switch this guy up again. We'll go with pink. So anything from 33 to 38. So that counts, that counts. 38. That's too big, too big. That guy counts. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. And you could also put these in order from least to greatest. That might also help you. Just depends on how you want that information organized for yourself. So the rest of them should all be between the intervals of, in the interval 39 to 40. Sorry, 39 to 44. I think I said that right. 1, 2, 3, 4, 5. All right. And if we add these all back together, we should get the 19 that we started with. It told us 19 shoppers at the top here, so I didn't read this guy out loud. Here are the shopping times in minutes of a sample of 19 shoppers at a local shoe store. The scenario doesn't necessarily change what it is we're going to do. No matter what, for creating a histogram, you're going to do the same idea where you're going to count the numbers in that interval and drag the bar up. This just gives us an idea of what we're looking at once it's created. And I do, in fact, have 19 there because 5 plus 5 plus 5 is 15, plus 4 more is 19. So I at least have the correct number, or number of values. Doesn't always mean that I counted correctly. I could have, accidentally put 1 in the wrong interval or 2 in the wrong interval. But we just want to make sure that we're paying attention there. All right, 5 number summary. So I'm going to get a new guy here so I don't have to worry about that. So when we're looking at this is another way of looking at data. It tends to be a little bit more confusing, I think, than it needs to for students. It's 5 number summary plus an interquartile range. It's 6, not even calculations. I think calculation is a strong word for this one. It's kind of 6 very simple numbers that we're going to grab from this list. And what it does is it divides the list into 4 equal pieces. And that's literally our goal here. So we can see we have a minimum, lower quartile, medium, upper quartile, maximum, interquartile range. So what do these mean? And I'm going to erase this because I like to do this right off the list here. I'm a little bit lazy there. I just didn't want to rewrite my list. So for minimum means the smallest number. So I'm just going to come over here and go, well, the smallest number, here's my minimum. It's 53. So I already have my minimum. That's all minimum means, is what's the smallest number. Maximum, that's the second easiest one to get, is what's the biggest number. And if you notice, these even say they're ordered from least to greatest. And these are the temperatures in Fahrenheit in 12 U.S. cities. So it's giving us some temperatures here. Again, if it's not in least to greatest, you need to put it in order from least to greatest. So far, when I've been doing these on Alex, they're always in order from least to greatest. So I haven't had to mess with that at all. All right, the third easiest thing to get, and really the order of these doesn't matter how you get them, they're all 3 easy to kind of get, is median. Well, we need to remember, what does median mean? So median, if we've ever, driven on the freeway, hopefully we know that the median is that big block in the middle, right? It's the separator on the freeway, the median. It can also be on kind of regular streets too, if you have enough space there. So it's kind of the same idea in the numbers. As long as they're ordered from least to greatest, the median is the middle. So if I have 12 cities, well, 12 divided by 2 is 6. So it's going to evenly divide into 6. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. So when I have this case, I'm not literally going through a number here because there's 6 on this side and 6 on this side. What I have to do is I have to add these 2 together and then divide by 2, because I want to know literally what's in between them. I want to know what is exactly in the middle here. So I would go 66, let's see, that's 6 plus, so divided by 2, and we would get 63. So 63 is my middle, or my median. And then lower and upper quartile. So again, tends to throw students off pretty bad with the lower quartile and upper quartile. if you remember what I just said, we kind of divided this into two pieces. Here's 6 numbers, and then there's another 6 numbers on the other side. Lower quartile literally means the lower numbers on the first half. So it's the smaller numbers, right? So lower quartile. And quartile is another word for the median. It just has to do, because we're dividing it into quarters, 4 equal pieces. So quartile has to do with one of those 4 pieces. So hopefully quart and quarter, we can kind of relate those two things. So we're going to find the center, the middle of this piece. That's all lower quartile means. It's the middle of the first half. So we have 6 numbers, 1, 2, 3, 4, 5, 6, and this one's included because it's not actually part of the median. It's just attached there so we can get the middle. So my median would be right here for this piece. Here's my middle. Again, I have 2 numbers. I need to know what's in between them. I want to know the actual middle. So I'm going to go 55 plus 59 divided by 2. And let's see, I'm going to get 14 and 11. So, and then divided by 2. And I did that right? 14, carry the 1, 10, 11. Yeah. And then I'm going to divide by 2. So I'm going to get 57. And that makes sense because, you know, if I go 56, 57, and then 58, 57 if I went down. So 57 is my lower quartile. And then, let's see, I'll do it in red, I guess. I'm going to look at the upper half, or the second half of the numbers, the bigger numbers. And I'm going to do the same thing. Upper quartile means what is the middle of the second half. So I'm going to go 1, 2, 3, 1, 2, 3. So I land right here. I still have 2 numbers on either side, but it's the same 2 numbers. So if I say 71 plus 71, and then I divide by 2, I'm going to come right back to 71. So if it's the same 2 numbers, you can always kind of remember that. The average of 2 numbers added together, if it's the same 2 numbers, is that number. So there is no other middle in between them. What's in between 71 and 71? Well, nothing. 71 is the number that we're looking for. All right, so that's the kind of basic calculations there. That's why I was saying kind of calculations is a strong word. Yes, we're doing a few things here, but it's not super crazy calculations. A lot of it's middle. I want to find the middle of all of it, the middle of the first half, the middle of the second half. That's all these mean. We just have to, you know, keep in mind that we're having a new word thrown at us, which is quartile. If you don't remember the word median, then 2 new words thrown at us. The last piece here, which is, you know, our third possible new word, is interquartile range. So what that means is I want to take the lower quartile and the upper quartile and subtract them. I want to know how far apart are they. So I'm going to take the upper quartile and I'm going to subtract that from the lower quartile. That way I don't end up with a negative. You always want to do the upper from the lower. So the upper quartile was 71 and the lower quartile was 57. So I just want to subtract these two guys. So let's see, what do we get there? I'm going to stack them because that's a little easier to picture for whatever reason. 11, so I get 4 and 1. So there's a difference of 14 there. So the range is 14, or the interquartile area is going to be 4 pieces long. And we're going to make what looks like a box in Whisker Plot, and we're going to do that on the very next screen here, where it looks something like this. So it's got a box and it's got 2 whiskers. Here's the lower quartile, here's the upper quartile, and here's the median. So we plot 5 numbers, and we just put a box around the 3 kind of middle ones. The 2 on the ends, we consider those not necessarily outliers, but they're kind of on the outside. But each one of these areas, so we have 1 area, we have 2nd area, 3rd area, 4th area, so we have 4 areas here, right? 4 sections. And you have to remember that they all represent the same number of values. So the first area represents the first 3. The second area represents the next 3 numbers. Then we have the next 3 numbers and the next 3 numbers. So we literally divide this into 4 equal pieces. So from here it goes 53, 54, and 55. And we created a range right here based off of that. And then the next numbers is 59, 61, and 62. and there's a piece that corresponds here. So it has to do with these numbers and how spread out they are. So that's how, like, some of the time we'll see a box where it's very small at the beginning and large on the end, because these ones are closer together, and then the next three numbers are farther apart. So remember, that's kind of the spread here on the boxes, and we're going to see this kind of being built on the next screen. So we're going to do the same kind of calculation on the next screen, and we're going to build a box and whisker plot. Okay. All right, let me grab my data. So now we have the following are the ages of 16 music teachers in different school districts. And I'm going to extend this guy down. And whoop, there we go. There it is. Okay, so now I'm just going to do the same thing I kind of did there. And it says notice they're in order from least to greatest. So yay, they're kind of the way we want them to be already. Which is very nice. So far, I've always seen Alex put them in least to greatest. So we still want to identify the 5-number summary. In this one, the interquartile range, we're not necessarily going to note that anywhere. But we do need to know the minimum. And we need to know the maximum. So the minimum, and we can drag this as we go. We can wait till we get to the end. Totally depends on your preference. You might want to find all 5 numbers and then go over here and graph. But I can go over here and say, okay, well, the minimum, which is this first whisker, it's the least number is 30. So I need to drag it all the way to 30. And if you look up here above, I can see the 30 there. So that works. So I can drop that there. My maximum, which is going to be my other whisker, is 55. So I'm using the entire graph here. I'm going from one side all the way to the other. Now we need to find the numbers in the middle here so I can move them. So now I need my median. Remember, that's the middle. So if I have 16 music teachers, that means that it's going to divide into 2 equal halves. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8. And if I count on the side, 1, 2, 3, 4, 5, 6, 7, 8. I need to add these guys together. So 42 plus 43 and then divide by 2. So that's going to be 42.5 because I know it's going to have a 0.5 on it. So this is my median. This is my middle. So I can take this guy and I'm going to say, oh, look at that. It already is on 42.5. I don't even need to move that. That was just a lucky by chance where they put it. All right, so let's go to the next piece here. So we're going to do the lower quartile. Remember, that's the middle of the lower half or the first half. 42 is included here because that's not actually the middle. It was just part of my calculation. So I have 1, 2, 3, 4, and 1, 2, 3, 4, right? So I need to look at these two numbers that are on either side. They're both 36, so my lower quartile is 36. So I need to take this guy and drag it down to 36. All right, and then I'm going to do my upper quartile, which is the middle of the second half. So I have 1, 2, 3, 4, 1, 2, 3, 4. I have 2 numbers there. So, and they haven't given us an example yet where we land right on top of a number. Sometimes there is an odd number of values. And if that happens, if you have an odd number of values, you literally land on top of a number. That is the middle. So you don't have to do this adding and dividing by 2. They're just by chance not giving us that example on here, darn it. So we have 49 plus 52, and we're going to divide by 2. So let's see, it's going to be 51.2. And I'm kind of doing it in my head real quick because I'm looking at how far away are they. They're 3 spaces away from each other if I go 50, 51, 52. And then half of 3 is 1, not 0.2, sorry, 0.5. So I'm just adding that kind of together, saying, well, if I add 1.5 to 49, I'm going to get 51.5. So I just I'm doing that a little bit in my head there. So we drag this over, 51.5. So now this is my box and whisker plot. All right, so this is just a visual of how the numbers are spread out. So I can take a look at the chunks I've created. So I've created 1 chunk, 2 chunks, 3 chunks, 4 chunks. Remember, we're dividing the numbers, basically the list, into 4 equal pieces. And then I can view how spread out they are just by looking at the whiskers. You know, is one whisker bigger than the other? Is one box bigger than the other? You know, I can take a look at these different pieces that we've calculated and decide, make decisions based off them, which we're going to do on the next section. All right, so let's go ahead and check. What did I do with the upper quartile? Two. Oops. I think this should be 50. Did I add that wrong? I think so. There we go. I had accidentally added wrong. I added 2.5 instead of 1.5. Oops. All right. So that was section 2. I will see you in section 3.